Infinite sequences, sigma notation. What are they? Sequences are a list of numbers or objects in a special order. Sigma notation is a method to write out a long sum in a concise way. Why? Helps with repeated addition. Interesting fact, female polar bears usually only weigh about half as much as males. Now, let's take a look at the examples we're going to discuss in today's video. Before we take a look at example 1, let's look at the notation and some theorems. First, we have sigma notation. The weird E is the capital Greek letter sigma. The M on top is the last number that we want to use. K is the index, and 1 is the first number that we want to use. Finally, A sub k is the sequence that we use to find the sum, whether it is the partial or its entirety. The first theorem we're going to look at is the theorem on sum of a constant. Statement 1 we can only use when the sequence is constant, and the first number that we want to use is 1. To find the sum, we multiply the top number by the constant. The second statement is when we want to find a partial sum, or when the bottom number is not 1. Let's talk about why we multiply the constant by the quantity of m minus p plus 1. Let's say we have the numbers 1 through 3. Do we have one number, the number 2, or 3 numbers, the numbers 1, 2, and 3? That's right, we have 3 numbers. We have to add back 1 because we're counting, and not finding the distance between 2 numbers. Next, let's take a look on the theorem on sums. If a sub n and b sub n are infinite sequences, then for every positive integer m, we have 3 statements. Statement 1 is if we have 2 different sequences, we can separate them, and find the sum of each one individually, then add the 2 together. Statement 2 is just like the first one, except with subtraction. And statement 3 is we can factor out a constant if need be, then multiply it at the end. Now that we know the notation and seen all the theorems, let's start example 1. Let's read the steps. Step 1, find the first term. Step 2, find the next, and the next. Step 3, find the sum. Now, let's read the question. Find the sum of the summation of 5 as k goes from 1 to 4. We already have the theorems that we might use on the top right. First, let's use statement 1. Since we only have a constant and our first number is 1, we can multiply the top number and the constant, or 4 and 5, which is 20. That is the first way to find the sum. Now, let's use statement 2. So let's substitute 4 for m, 1 for p, and 5 for c. So we have the quantity of 4 minus 1 plus 1 times 5. And 4 minus 1 plus 1 is 4. And 4 times 5 is 20. That is the second way to find the sum. Now, let's use the plug and chug method. Our first term is 5. Our second term is 5. Our third term is 5. And our fourth term is 5. So we have 5 plus 5 plus 5 plus 5, which is 20. That is the third way to find the sum. Which method do you prefer? The first one, the second one, or the third one? They all gave us 20. That is example 1. Let's move on to example 2. Now, let's read the question. Find the sum of the summation of 5 as k goes from 4 to 6. First, let's use statement 1. Whoa, wait a second. There's a problem here. What do you think the problem is? That's right, we can't use statement 1, since our first value is 4, and not 1. So let's use statement 2. Let's substitute 6 for m, 4 for p, and 5 for c. So we have the quantity of 6 minus 4 plus 1 times 5. And 6 minus 4 plus 1 is 3. And 3 times 5 is 15. That is the first way to find the sum. Now, let's use the plug and chug method. Our fourth term is 5, our fifth term is 5, and our sixth term is 5. So we have 5 plus 5 plus 5, which is 15. That is the second way to find the sum. Which method do you prefer? The first one or the second one? They both gave us 15. That is example 2. Let's move on to example 3. Now, let's read the question. Find the sum of the summation of 2x plus 4 as k goes from 1 to 3. Let's use the plug and chug method. So a sub 1 is 2 times 1 plus 4. A sub 2 is 2 times 2 plus 4. And a sub 3 is 2 times 3 plus 4. Let's multiply the numbers. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. Let's add the numbers in the brackets. 2 plus 4 is 6. 4 plus 4 is 8. And 6 plus 4 is 10. So we have 6 plus 8 plus 10. And the result is 24. That is the plug and chug method. That is example 3. Let's move on to example 4. Now, let's read the question. Find the sum of the summation of 2k plus 4 as k goes from 1 to 3. Whoa, we had the same question. But this time, we're going to use the theorems. Which theorem do you think we're going to use first? That's right, the theorem on sums, where we can separate the two infinite sequences. So we have the summation of 2k as k goes from 1 to 3, plus the summation of 4 as k goes from 1 to 3. We can still use one theorem. Which theorem do you think we're going to use next? That's right, the theorem on sums, where we can move the constant out in front. So we have 2 times the summation of k as k goes from 1 to 3, plus the summation of 4 as k goes from 1 to 3. Now, let's find the sum. Let's write down the sum of the first summation, 2 times the quantity of 1 plus 2 plus 3. Now we're going to use a theorem. Which theorem do you think we're going to use? That's right, the theorem on sum of a constant. Luckily for us, the first value is 1, so we can multiply the last value in the constant, which is 3 times 4. So we have 2 times the quantity of 1 plus 2 plus 3 times 3 times 4. Let's find the sum. 1 plus 2 plus 3 is 6, 3 times 4 is 12, 2 times 6 is 12, and 12 plus 12 is 24. That is how we use theorems to find the sum. That is example 4. Which method do you prefer? Plug and chug, or breaking down the sequences into multiple parts? Let me know. Now it is your turn, so go ahead and pause the video here so you can take your time to answer this question, and I'll show you the result in 3, 2, and 1. Did you get it correct? Fantastic. If not, there's always tomorrow.